Hey, and welcome back. Today, we're going to be talking about synthetic division. So, synthetic division is a method of finding the factors of polynomials that are larger than quadratics. I'm talking about cubics, I'm talking about quartics, that type of thing. And the method by which you want to do this is somewhat different from how you would want to factor a quadratic. So, we'll run through it with this example right here. So, first off, we want to set the function equal to 0, right? F at x. The second step is that we want to find an x value that works. Now, I'll get to what that means in just a second. The third is that we want to put the coefficients into a row. Then we want to start adding and bringing numbers down. We write our new factored form, and then we repeat the process essentially from the beginning. So we go right back up there. Okay, so for f at x is equal to x cubed minus 3x minus 2. So one thing that you might remember from our quadratics video is that if ever there's something that doesn't look very easily factorable, we can always turn to our quadratic formula. That would be true, except we do have that cubed right there, which means no matter how hard we want to, we cannot plug that into quadratic formula. So the first step is we're going to set it equal to 0. So we'll have 0 is equal to x cubed minus 3x minus 2. That's step 1 there. So for step 2, we want to find an x value that's going to produce 0 in this equation. So in this case, I'll show you what I mean. Let's say that we plug in positive 1, for example. So 0 is going to equal 1 cubed minus 3 times 1 minus 2. Or 0 is going to equal 1 minus 3 minus 2. And that is going to give me negative 4, which is not equal to 0. So we know that we can't use positive 1 in this equation. But let's say that we try x is equal to negative 1. So in this case, I'm going to get that 0 is equal to negative 1 cubed minus 3 times negative 1 minus 2. In this case, that's going to give me 1 plus 3, that should be negative 1, minus 2, or 3 minus 3, or 0. So I find that negative 1 does work in this equation right here. From step number 3, what we're going to do is we're going to write the coefficients in a row. And I'm going to show you how you want to do this. So we'll write out our table a little something like that. And you see that the coefficient on x cubed is 1. So we start by writing 1 there. The coefficient on x squared, you can see that there is no x squared, so we're going to get 0 there. For on x, we get negative 3. And on just the reals, we get negative 2. And we're going to add to this negative 1. So we're done that step. Now we want to move on to step 4, which is going to be represented by everything in yellow. So we're going to bring our numbers down, right? So 1 comes down here. We get 1 there. Now we multiply 1 by negative 1, okay? And the product of those is what gets added into this column right here. Okay, so now we go 0 minus 1, or 0 plus negative 1. We get negative 1 there. Negative 1 gets multiplied by negative 1, and that gets added here as 1. Okay, so same process here. Negative 3 plus 1 is going to give me negative 2. I'm going to multiply that by my negative 1, which gives me positive 2. And I'm going to rewrite that right there. Now finally, negative 2 plus 2 is 0. And because we don't have any numbers left in our synthetic division equation, there is nothing left to write there. So I'm just going to write there that that is step number 4. Okay, so for step number 5, we want to rewrite the factored form. So 0 is equal to, you might remember that we factored out an x, x is equal to negative 1. So we're going to go x plus 1, right? Because we are subtracting the factor. And how we write this is we're going to write it in as the coefficients again. So x squared minus x minus 2. Okay, so for step 6 and beyond, we are going to repeat synthetic division for this polynomial right here. So we're looking for numbers that are going to make f at x is equal to x squared minus x minus 2 equal to 0. So in this case, I'll get you to go ahead and try plugging in a random number to see if you were able to find something that gets equal to 0. Okay, so what I got is that we can plug in 2, right? So 2 squared minus 2 is 0. That's going to give me 4 minus 4 is equal to 0, which is in fact equal to 0. So what we can do is we can start rewriting it on the other side. Continuing from there, we are going to have plus, and we're going to rewrite the coefficients here in here, remember? So on x squared, we have 1 now. On x, we have -1. And on the reals, we have -2. And to that, we are going to add +2. So we just start by bringing the 1 down, right? We can imagine we have a 0 there. So 1 plus 0 is 1. Now we multiply that 1 by 2, which gives me 2 there. -1 plus 2 is 1. And now we multiply that 1 by 2, which gives me 2 there. -2 plus 2 is 0. So if I were to go back to my factored form, I have the x plus 1 that I factored out before. Now I have my x minus 2, right? And what I'm left with from here is 1 in the x column and 1 in the numbers column. So x plus 1 as well. Now I can rewrite this as 0 is equal to x plus 1 squared, x minus 2. And just like that, I have successfully factored my original polynomial, which was x cubed minus 3x minus 2, using synthetic division. Okay, so we're going to try it a little bit faster now with g at x. So we have x cubed minus 3x squared minus 6x plus 8. So step 1 is we set it equal to 0. So 0 is x cubed minus 3x squared minus 6x plus 8. Now for the second step, what we're going to do is plug in numbers until we find something that is going to make this equation true. In this case, the number 1 happens to work. So 0 is equal to 1 cubed minus 3 times 1 squared minus 6 times 1 plus 8. It doesn't really matter if we cube 1 or square 1, doesn't make a difference in what it is. We're going to get 9 minus 9 or 0. So we can move into setting up our synthetic division formula. So I'll switch colors there. 3, and we're going to have to write our coefficients, right? So on x cubed, we have 1. On x squared, we have -3. On x, we have -6. And on numbers, we have 8. And to that, we're going to be adding 1. So 1 gets passed down to start. We have 1. We multiply what we have down here by what's up top there. So 1 times 1 is 1. Now -3 plus 1 is -2. And we repeat the process. -2 times 1 is -2. -6 plus -2 is -8. And we multiply that -8 by 1. That gives me 8 minus 8 or 0. So kind of integrated step 4 into there as well. What we find is that 0 is equal to x minus 1. Now we're going to rewrite our factored form from these coefficients here. So x squared minus 2x minus 8. And we're going to restart from this equation here and keep going. So we're saying that 0 is equal to x squared minus 2x minus 8, and we need to look for something that is going to work here. So in this case, we can actually plug in 4 to the equation. So 0 is equal to 4 squared minus 2 times 4 minus 8, which is going to give me 16 minus 8 minus 8, or 0. So exact same setup as before. And if you'd like, you could just write the same coefficients as what's down there up here. So 1, -2, and -8. We're going to add to that. We have the number 4 up here. So 1 plus 0 is 1. 1 times 4 is 4. -2 plus 4 is 2. 2 times 4 is 8. -8 plus 8 is 0. So for our final factored form, what we come across is that 0 is equal to x minus 1, x minus 4, x plus 2. And because we don't have any like terms, this is as far as we can simplify it. So one interesting thing about synthetic division is that you aren't restricted to cubics when you use it. You can use it for quadratics and linear stuff, as we've seen. Not that there's really a point to using it for linear stuff. But you can also use it for quartics or quintics or higher order functions. So here we have h at x, which is a quartic function. We're going to go ahead and factor this. So first off, we find that 3 is a factor. So steps 1 and 2 should be reasonably obvious for how to check. I'm going to skip ahead to step 3. So we have 1, -1, -17, 21, and 36. So I'm going to go plus there, and we just checked for 3. So we pass the 1 down, we're going to get 1. 1 times 3 is 3, so we write that there. And we're just going to keep going through this. So -1 plus 3 is 2. 2 times 3 is 6. -17 plus 6 is -11. 3 times -11 is -33. 21 minus 33 is -12. It's going to give us 36, and that gives me 0 there. So we're at the point of x cubed plus 2x squared minus 11x minus 12 times x minus 3 is equal to 0. So we're going to continue on with synthetic division. We find that you can actually do 3 again in this equation. So we're at 1, 2, -11, -12, and we're throwing 3 in again. So we go 1 there. 1 times 3 is 3. 2 plus 3 is 5. 5 times 3 is 15. -11 plus 15 is 4. 4 times 3 is 12. -12 plus 12 is 0. So what this gives me here is x squared plus 5x plus 4 times x minus 3. And we have another x minus 3 term, but remember that we can just express that as x minus 3 squared is equal to 0. So from here, you have the choice. You are working with a quadratic, which means that you can use synthetic for it. Or you already know how to factor quadratic formulas from some of my previous videos. If not, then I'd recommend going back and checking those out. But basically, this is going to factor into x plus 1 and x plus 4. And obviously we still have that x minus 3 squared is equal to 0. So what we find is that the factored form of h at x is equal to x plus 1, x plus 4, x minus 3 squared. Okay, and finally for this example here, we have demonstrate that the factors of I at x are equal to x cubed minus 9x squared plus 8x plus 60 are -2, 5, and 6 using synthetic division. Basically, I have given you the numbers there to work with, so you don't have to do guess and check to find out what they are. You can plug in the numbers and get started whenever you're ready. Okay, so assuming that you have tried the problem, we're going to start by plugging in -2 to this equation. So we're going to get 0 is equal to -2 cubed minus 9, -2 squared plus 8, -2 plus 60. Well, this is going to give me -8 minus 9 times positive 4 minus 16 plus 60. So combining this stuff together, I'm going to get -24 minus 36 plus 60, or 0 is negative 60 plus 60, or 0. So we can proceed with synthetic division here, is the good news. So we're going to, first off, put all of our coefficients in. So 1, negative 9, 8, and 60. But we're going to have the plus here and negative 2 there. So we bring the 1 down, that's 1. 1 times negative 2 is negative 2. Those add to negative 11. Negative 11 times negative 2 is 22. 8 plus 22 is 30. 30 times negative 2 is negative 60. And 60 minus 60 is 0. So what we find from there is that 0 is equal to x squared minus 11x plus 30, x plus 2. So from here, we could just use simple quadratic factoring, but the problem wants us to proceed with synthetic division. So we're going to take 5 as being the answer here. So let's say that we have 0 is equal to, and we only care about this portion right here, plugging it in there. So 5 squared minus 11 times 5 plus 30. Well, that's going to give me 25 minus 55 plus 30, or 55 minus 55, or 0. So continuing with synthetic there, we're going to get 1, negative 11, and 30. And remember that we have 5 up top there. So we bring the 1 down. 1 times 5 is 5. Negative 11 plus 5 is 6. Sorry, that should be negative 6. Negative 6 times 5 is negative 30. 30 minus 30 is 0. So what we find is that I at x is going to factor to equal x minus 6, x minus 5, x plus 2. Okay, so that is everything for synthetic division. Thank you very much for your time, and I hope that you learned something valuable.